Hello everyone, welcome back to Engineering Space, where engineer breaks the border of engineering. In today's video, we're gonna continue our lecture about data science, and in today's video, we're gonna learn about how to predicting house prices using multiple linear regression. So, as introduction, in this project, we're going to see how machine learning algorithms help us to predict house prices. Linear regression is a model of predicting new future data by using the existing correlation between the old data that we provide. Here, machine learning helps us to identify relationship between future data and output so we can predict future values. So, what we need, of course, we need to use Anaconda and Jupyter as our main code navigator, and also we need to SQL library, and after that we need a data set in CSV format. So as you can see in this window, I just provide a simple data that we're gonna use with. There are 4 variables. The first is area, and also the room, and the building age, and the last is the dependent variable, which is the price of the house. So, and after that, after we provide the scalar library that we're gonna run on Jupyter Radar, and also a dataset in CSV format, the last we are going to use multiple linear model regression to predict the house pricing. So let's back to the Anaconda. Let me just choose Jupyter here. Wait for a moment, and then you're gonna be brought to the you will be bring to the new window, and then let me just choose the Python kernel here. And yeah, as the first step, we need to import our scalar library. So the first step, I will type here, and then let me just run it. After that, okay, there a typo here. Let me just alright. So after that, we need to also import the sklearn. Okay, there is also a typo here. We should put underscore if we have a space between two words, and after that, we try to import the sklearn directly. So after that, we need also to import the dataset that we have provided previously. Type here as dataset file will be equal to pd read the csv files braces. So I just forget to put the comma here. So after that, we try to run it and successfully try to control it, and yes, as you can see, now our data was successfully imported. If you want to compare it between what we have data in Excel within this on our Jupyter notebook, simply just compare it here, and you're gonna see the equal data from our Excels and in Jupyter notebook. So right now, we're gonna try to define a new system to show our data. Simply just type here one more time for area, and after that, the room count, Remember, don't forget to put underscore if you have a space, and after that put the comma again, and also the building edge. So after that, try to run it, and you now have better view for three variables: the area, room count, and building edge. So after that, we're gonna separate it and show our data for only the price of the building. And so now you have price dataset as dependent variable, and now we also have the second variable that compare between the area, room count, and building edge, and with the dependent variable is price itself. So after we completely running this script, now it's time for us to predict the prices of the house by linear model regression. Let me jump to it by typing here regression equal to linear model dot linear regression. Put the braces. Let me put under the script is reg dot fit and open braces. So yeah, this is the final script for try to predict the price of the house later. Let me try to run it. Okay, we got something that not closes the command. Let me check it once again. Linear regression. So we put the wrong braces here. It should be like this one. So yeah, this is the sign that we have successfully imported the linear regression script on our notebooks, and now it's time to predict. So let's say we're gonna predict the price of the building with, let me put here, let's say we are going to predict a house building with h equal with area equal to maybe 320 millimeter square, and then with total of room equal to 5, and then the last variable, the age of the building, equal to 5 years old. So to predict this variable, all we need just type here like this one. Open the braces and put all the number 320, spare it with comma, and then put total of room 5, and then the age of the building 5. So you're gonna get the price of the building by press run or enter. Okay, as shown here that there are warning X doesn't have valid feature name, but our system automatically take fitted with features names by putting the array, and we're gonna get the price based on the prediction of the machine. We're gonna gather this amount that is 111,583 dollars. So let's say you're gonna predict there's so many options, like maybe I just type here you're gonna predict in, so just put it here. You may put any possible prediction that you need. Yes, type it here, let's say 215, and then also with 4 room count, 10 years old. And after that, let's say we're gonna put 230 meters square with room count 6 room, and then 0. And then the next one should be, let's say 357 with 3 years old, and also the last is 20 years old. 3 building, 3 room and 20 years old. Let's try to run it, and you can get the price here, here, and here. So before we close our lecture, I think I need to also give you the other way to doing linear regression analysis. So let me type here to get the coefficient, and then we got the coefficient here, and after that I will do intercept. And now it's time for us to jump into the last multiple linear model regression formula using this formula, which y equal to a plus b1 x1 plus b2 x2 times n plus b3 times x3, and etc. So a should be equal to regression intercept that we have already take the result previously, and b1 should be coefficient for variable of in 0 column in here, in here, and after that p2 should be equal to coefficient in the first column, and p3 should be coefficient in the second column. So after defining it, let's back to our formula, which we're gonna put the x1 x2 x3, which is the variable that we would like to define. So I'm gonna put here x1 equal to, let's say we're gonna take the similar here, like this one maybe. So variable 2 should be 4 room of the building, and variable 3 should be the age of the building, which is 10 years old here. So after that, we're gonna try to put the formula, which is y equal to a plus b1 times by x1 plus b2 times by x2 plus b3 times by x3. So y equal to, this is the final formula for our last lecture here for multiple linear modular equation. Let me try to run it and we're gonna see the result. Is it equal? Let's compare it with this one. So you can have same number, not all the number but almost same, with the amount here is $515,000 or yeah, $515,914. So yeah, I think that's all for now. Thank you for your attention, guys. If you need to get all of the research or codes here, simply just go to our description or in the comments below, and we have provided you the example of dataset and also research code on our lecture for this session. So thank you, see you on the next video, and Assalamualaikum warahmatullahi wabarakatuh.